Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. In this video, we're going to go over the basics of capacitance. I've always thought of capacitors as small batteries. That's not very accurate, but it helps me to think of capacitors in that way because they can store electricity. For this experiment, we're just going to show you how they charge and how resistance can affect the charge time of a capacitor. The circuit I've set up is off a 9-volt battery. It goes out across this rail, down through this resistor, over through the capacitor, and down and back to ground. I have a 1K ohm resistor and a 10 millifarad capacitor. Capacitance is measured in farads, whereas resistance is in ohms. In this circuit, I'm measuring the voltage across the capacitor. So when I start it up, you'll see the capacitor start to charge. And you can see that it's charging at a certain rate. But you'll notice that as it approaches 9 volts, the rate will slow down. You can see that it took longer to get from 7 to 8, and then 8 to 9, and as it approaches 9, it just steadily gets slower and slower and slower. We'll go over how to calculate in a later video. I just wanted to show you that that phenomena exists. I'm going to stop the simulation. I'm going to show you what happens if you change the value of this resistor down from 1K ohm to 500 ohms. By reducing the resistance, you increase the rate at which the capacitor charges. You can see that it's getting up there much quicker. And also, the inverse is true. As you raise the value of the resistance, it takes longer and longer to charge. The same is true of the capacitor. If I raise the capacitance, it will take longer to charge. Increased it by 10. And you can see that it's taking longer now to charge. One of the things you'll notice is that it charges quick and then slows down. The same thing happens on discharge. It discharges quickly and then slows down as the charge leaves the capacitor. And that's the basics of capacitance. Like I said, in a future video, we'll go over how to calculate the curve and how quickly a capacitor is going to charge. You can use it for timing events. They call them RC time constants or resistive capacitive time constants. We went over a basic study of capacitors in this video. Thanks for watching.